Hello, Life Science class. This is our 20B notes. We're going to talk a little more about our homeostasis, right, our internal balance, only this time we're going to go a little more in depth involving the circulatory system. We want to talk about what the different parts are. One of the things we looked at in the last group of slides was the fact that we have red blood cells, white blood cells, platelets, right, all the things that are floating in our circulatory system. Now we need to talk about the blood vessels that are part of that system. We have a closed circulatory system. That means our blood stays contained in our veins, arteries, and heart. Something important for us to remember is arteries, which starts with an A, carries blood away from the heart. Capillaries are a little bit more finely divided, and veins are going to be what carry blood back to the heart to get a fresh supply of oxygen in the lungs and travel to the rest of the body. Okay, blood vessels. We're going to talk about our veins. Are thinner walled than the arteries. They have one-way valves to keep blood from going the wrong direction. Muscle contraction also helps moving blood in the veins. Our heart is going to pump about 60 to 80 beats a minute, and it has a pacemaker that helps keep the pace very steady. We have a material called pericardium that helps to give the heart a slippery surface so that it reduces friction. We have 4 chambers in our heart. 2 of them are upper chambers called atria, and 2 of them are ventricles, lower chambers of the heart, a little bit thicker walled. And we have a division between the 2 parts of the heart called the septum. When we look at the heart, blood enters through the atrium and leaves through ventricles. Okay, so we have 2 atrium at the top of the heart and 2 ventricles at the bottom of the heart. Whenever blood enters the heart, whether it's full of oxygen or whether it's has a lack of oxygen and it's deoxygenated, it's always going to enter the atrium. Okay, I want you to think about this. The atrium of a building is its entryway. Okay, so blood is always going to enter into the top part of the heart. It may be the right side, it may be the left side, just depends on where the blood's been coming from. We have atrioventricular or AV valves that are going to allow the blood to flow in only one direction. We have semilunar valves, which are going to keep the blood out once it leaves, right? So it can't re-enter and come back in again, the wrong direction. This structure of our drawing of our heart shows what we've been talking about. This is an atrium, this is an atrium. This is a ventricle, this is a ventricle, and here's the septum that divides the 2. Blood coming into the heart always enters the atrium. It's going to travel through the valves going into the ventricles, travel out of the heart, go maybe to the body, give off its oxygen, come back in to the atrium, travel through the valves, go to the ventricle, leave the heart, go to the lungs, get fresh oxygen, come back into the heart. Okay, so it's just a diagram, the arrows there, similar to the one in your book. Okay, path of the blood, blood from the body. What I just said about where the blood goes, we're going to talk about that now. Blood from the body returns through 2 veins. The superior vena cava, which comes from the top half of the body. The inferior vena cava means blood is coming from the lower half of the body. All of this blood is deoxygenated. It's been to all of the body parts. It's given off all of its oxygen. It's taken on carbon dioxide, so it's deoxygenated blood, a dark maroonish red color. It's going to enter through either the top half or the bottom half, superior or inferior vena cava, into the right atrium. Okay, so whether it's coming from the top half or the bottom half of the body, both kinds are going to enter on the right atrium. Once the blood gets into the right atrium, it's going to travel through the right AV valve into the right ventricle. Ventricle, remember, the blood is always exiting from here, so it exits from the right ventricle and goes to either the semilunar, through the semilunar valve into the pulmonary artery. So your deoxygenated blood that entered the right atrium is going to now need to go to the lungs to get rid of its carbon dioxide and pick up a fresh load of oxygen. So the blood has left the heart and is now going to be oxygenated in the lungs. Then it's going to travel through the pulmonary veins back into the heart. This time it's entering the left atrium. Travels through the left AV valve, goes to the left ventricle. Remember, the ventricle is always going to be the place the blood is leaving the heart. It's going to exit through the semilunar valve, and now, this time, instead of going to the lungs, it's going to the aorta. The largest artery in the body is going to pass that blood throughout your whole body, delivering oxygen and picking up carbon dioxide. The veins, right? Veins are going to carry blood back to the heart. And so we have here a representation of our lungs, our top of our body organs, our bottom of our body organs. The walls of the ventricle are thicker than the walls of the ventricle. The walls of the left ventricle are thicker than the walls of the right ventricle. The heart's nourishment comes from two coronary arteries that provide oxygen, fresh oxygen, to the heart itself. The atrium are going to work together. The ventricles are going to work together. So blood is going to enter the atrium and leave the atrium at the same time. Enter the ventricles, leave the ventricles at the same time. So you get this lub-dub kind of bum-bump, bum-bump sound. Sometimes there's a heart murmur or an arrhythmia that shows the fact that that blood is not passing through correctly. Blood pressure, we could test our pulse by counting how many beats per minute. Our blood pressure is going to be the pressure that circulates the blood against the walls of the arteries and passes the blood through our bodies. Low blood pressure can be a problem, and high blood pressure can be a problem. Low blood pressure, there are ways to increase the blood pressure by pumping blood faster, getting a faster heartbeat, or constricting, like closing your blood vessels. High blood pressure can be a problem. That shows overworked heart. The blood vessels are going to wear out sooner than they should. Various diseases can be cause of this high blood pressure. Factors for high blood pressure could be genetic related or related to tension or your diet. Thank you. That's the end of the 20C notes.